All right, we're going to talk about what we call the kinetic molecular theory, or KMT of gases. So just look at the words real quick. Kinetic, that means motion. It's the opposite of static. So this is the theory that explains gas behavior based on their motion. That's all it is. And there's 5 parts to it, and we're just going to go through them one at a time. 1, and this is going to be a little boring, sorry. A gas consists, good way to preface a video, huh? Of tiny particles moving randomly. Okay, and when we say particles, we mean molecules or atoms. All right, so we have tiny little particles, and their volume the volume of the particles is negligible compared with the volume of the gas. So let me just give you an example of this real quick. Let's just talk about 1 mole of water. So I'll see if you guys can think of what the volume of 1 mole of liquid water is. What volume would it take up? Well, it has a density of 1 gram per milliliter, a molar mass of 18 grams per mole. So 1 mole of water, liquid, is about 18 milliliters. Okay. As a gas, I'm just going to give you a rough idea of what it is. It's about 20 liters, and that's actually well, let's not worry about temperature right now. But if you look at that, that's about 20 milliliters to 20 liters. That's a 1,000-fold difference in volume. So if we say that the liquid, the molecules are touching, and in the gas, they're not, they've basically separated themselves 1,000 times further apart than they were before. So that's why we say the volume of the particles is negligible compared to the volume of the gas. It's 18 milliliters versus 20 liters, so not that important. Now, you can probably guess that that's not 100% true, but that's where we are for now. So gas particles, number 3, neither attract nor repel each other. So that's why those gases can mix homogeneously, because they don't attract or repel each other. All right, 4. Now this one's a bit long. Collisions between gas particles or particles and the vessel walls, so whatever is contained in a flask, a balloon, it doesn't matter, are elastic. What that means is the particles don't slow down when they collide. Okay, and there's a second part to that. Pressure is exerted vessel walls when particles collide with the vessel. So the gas particles run into the walls and they push on the walls, that exerts pressure. That's where pressure comes from. And number 5, average kinetic energy. Of gas particles is proportional to the Kelvin temp. And we always have to use Kelvin when we're dealing with gas laws. Never ever use Celsius with gases, okay? Because Celsius can give us negative values, and we cannot have negative values for things like pressure and volume, okay? So just to sum up, we have tiny particles. They're very small compared to their volume. The particles don't attract or repel each other. When the particle, and this is the important part, 4 and 5 are really the important part. Collisions between the vessel and the gas molecules, so gas molecules running into the vessel wall, that's what exerts pressure. And here's the other important part. The hotter the gas is, the faster the particles go, the harder they hit, the higher the pressure, okay? Maybe we should write that down. Higher temp, higher Kelvin temp, that gives us faster particles. Which gives us higher energy, let's say more energetic collisions. With the vessel, be it a glass flask, a compressor, balloon, does not matter what the vessel is, and therefore we get higher pressure. So we always want to think, when we're thinking about gases, we want to think about their temperature influencing their energy, how fast they're moving, and that energy influencing how fast and hard they hit the vessel walls, and that leading to pressure. Okay, and the reverse of this is also true. Lower temperature, slower particles, lower energy collisions, lower pressure.